Let's take a look at how to balance ionic equations. What are ionic equations? They are basically equations that involves ions. And what do we mean by this is, for example, if you have, let's say, hydrogen gas now, when hydrogen gas, when it ionizes, what do we notice here? It gives us H plus. Now, when you look at this equation is an ionic equation, even though it also has a neutral element there, but it also involves the ion, whatever. Now, what we do here is that the first thing you always do is that you balance the equation atomically. You have to balance it atomically. So what you notice here is that hydrogen here is 2, hydrogen here is 1. So you have to put a 2 at the back of your hydrogen. Then what do you notice here? It is balanced atomically. Then the next phase is to determine if it is balanced ionically. So what you notice here is that this is a neutral element. It is not in its ionic state yet. So therefore, the total charge here will be 0. And in this place, hydrogen has become ionized and it is H plus. So it has a charge of plus 1. But there's a 2 at the back of it. So which means that the total charge here is plus 2. And after figuring this thing out, the next thing you want to do is that you want to balance this thing ionically. How do you now balance equation ionically? You balance by adding electron. You balance by adding electron. And to determine which side you will add your electron, it will be the side which has the higher number of charge. So when you notice here, this is 0 and this is plus 2, which implies that I will need to add my electron to this right hand side because it has the higher number of charge. So how do we now go about that? You find the difference in the charge that both of them have here. So this is 0 here, this is plus 2. So the difference is 2, and that implies that I will need 2 electrons to balance this equation. So plus 2 electron. And if you look at it now, this equation is both atomically and ionically balanced. Let's take another simple example. Another simple example is the case of chlorine. So we know that chlorine exists as a diatomic element. So chlorine gas, what would that give us? That will give us Cl minus. Now, it has become ionized and then it has become Cl minus. So to balance it now, the first thing we want to do is that we want to balance this thing atomically. So there is 2 here and there is what? 1 here. So we have to put a 2 on this side. Now what do you notice here is that atomically it is balanced, but ionically it is not balanced. Total charge here is what? Is 0. Total charge here is 0 and total charge here will be -2. So which side has more charge? That will be the side with 0 because -2 is smaller than 0. So meaning that I will have to add my electron to this left side because it has higher charge. Now, what's the difference between the charge? 0 minus -2, that is plus 2. And what would that be? That will be plus 2 electron. And when you look at this thing very well, this is balanced. Now, whenever you are moving from a neutral state to a plus state, that is oxidation because there's increase in oxidation state, or whenever electron is being lost by something, that is oxidation. But whenever you are moving from a 0 state to a negative state, negative ion state, that is reduction because the process of adding of electron is reduction. So note that very well. Another way you can also see this is that there is increase in oxidation state for oxidation, and then there is decrease in oxidation state for reduction. From 0 to -1, that's a reduction. So, and from 0 to +1, that is oxidation. Quickly, let's now move forward. What if I now want to write a net equation for this entire thing? I want to write a net equation for this entire thing. What we notice is that as long as it's a redox reaction, a redox reaction is in such a way that you have your oxidation and you have your reduction. So based on the example that I've chosen here, so I'm just going to manage them. I'm just going to try to add them together. So the first thing you notice here is that electrons must be on different sides. If you have done your job very well, the electrons will be on different sides. So just like for this oxidation, electron is on the right. For this reduction, electron is on the left. And the next thing you want to take note is that you want to make sure that these two actually have the same number of electrons. If they don't, you have to balance this number of electron up. Don't worry, in some examples very soon, you understand what I'm talking about. So let's quickly get into it so that I don't take too much time. Now, let's take, for example, if you want to balance this particular equation, so if you have Cr2O7 2 minus plus SO3 2 minus to give Cr3 plus SO4 2 minus. Now, how do we balance this chemical equation? The first thing you want to do is that you want to write the half equations out. So half oxidation, half reduction. So here, you want to go to this place. You see that from chromium here in this place to this state, we have that. And now you see that here you have what? You have from SO3 2 minus to what? To SO4 2 minus. So let's say you don't even know how to determine which one is the half oxidation or which one is the half reduction yet. You don't really need to worry about that. So just name them randomly and say one is first half. So just say first half. You can determine what is going on later. So the first half, you can pick it for the chromium side. So let's write that out. So we have Cr2O7 2 minus, and this gives us Cr3 plus. So what's the first thing you would always do? You would need to follow this my step one after the other. You need to balance all the elements there atomically, excluding the one that has oxygen and hydrogen. So you leave hydrogen and oxygen out. You don't need to balance those two guys. So what your priority should be will be other elements to balance them apart from oxygen and hydrogen. So in this case, you can see that chromium here is 2 and chromium here is 1. So we need to balance it atomically. So what do I put there? I put a 2 at the back of this guy. So chromium is balanced. So what is now the issue that we have here? We have oxygen. Oxygen is not balanced. So I will not try to be, but in fact, you can see that there's no oxygen on the right hand side to even try to manipulate it and balance it. So how do you now balance oxygen? Don't forget, we are in the acidic medium. We are in the acidic medium. So in my next video, I'll talk about the basic medium. So you want to actually subscribe to my channel to get that video as well. So to go to the to balance oxygen now, what we always use is water. We will use water. So what you notice here is that we already have we have 7 oxygen on this side and no oxygen on the right hand side at all. So that implies that we will need 7 oxygen on the right hand side. So what you do is that same amount of water, you add it to your right hand side. So you have 7H2O. And that is the first thing you will do. So look for the number of oxygen that is deficient on one side and add that same amount of water. When you are done with that, what you notice is that you are now bringing in hydrogen into this whole thing. And then on this side, no hydrogen at all. On this other side, we have 14 hydrogen already. So to balance that hydrogen, what you will use to balance it is hydrogen ion, which is H plus, and that is 14 of it. So you must put 14H plus on this other side. Now what you notice now is that atomically you are okay because chromium here you have 2, chromium here you have 2, hydrogen here you have 14, hydrogen here you have 14, oxygen you have 7, oxygen you have 7. So atomically you are cool. Now let's now go further and do the ionically. So you see that this place is not balanced ionically yet. So let's see, this is a -2 state. So we have -2 here, and this is what? Plus 14. So total on the left hand side is plus 12. -2 plus 14, that is plus 12. And then in this place, you have 2 times plus 3, which is what? Plus 6. This one has no charge because there's no charge there. So you have plus 6. So what do you notice now is that there is a difference. We have plus 12 here, we have plus 6 here, which implies that the difference equals what? Equals 6. You have to add this electron. You have to add 6 electrons to one side of this equation, either the left or the right. So like I said earlier, you will always add to the side which has more charge. So and which is the left hand side. That means that I have to add 6 electrons to this left hand side. and that is what will balance this equation ionically. So let me quickly copy this segment out and paste it down here. So we'll have this here. So that implies that I need to add 6 electron to this side. So let me create a room for that. So we have plus 6 electron. And this equation is balanced both atomically and ionically now. So what do we notice here is that there is addition of what? There is addition of electron to this side. So does that mean that this is our reduction, or does that mean that this is our oxidation? We can still find that out. And then another way you can also find that out is actually by finding the oxidation number of chromium here, and then finding the oxidation number of chromium here. It's easy here, it is in the +3 state. So we notice that this is actually reduction. Why? Because the addition of electron. If you have to add electron to the reactant side, then that is going to be reduction. Addition of electron to the reactant side, it means that what? That is reduction. Now, let's go forward to the other half. So now this first half now, it is reduction half. So you can now properly name it as this is reduction half. So let's go to the other guy in our equation. The next one is SO32 minus to SO42 minus, SO32 minus to give SO42 minus. Now, so what you notice in this place is that we can easily see that this is the second half, and then this second half is oxidation. But like I said, since we don't know anything about it yet, let's also not call it anything. So let's just assume that it is just our second half. So I'll just name that second half. Now, the first thing we need to do here is to balance it atomically, ignoring oxygen and hydrogen if they are present. So what you notice here is that we have 3 oxygen here and we have 4 oxygen here. One side is deficient, and which side is that? That is the left hand side. So the deficiency is by 1, so that implies that all I need to balance this is just 1 molecule of water. Like I've explained earlier, look for how many oxygen you need and you balance the equation using that number of molecules of water. So 3 oxygen here, 4 oxygen here. We need 1 more here to balance the whole thing. So I had that. Now, what that implies is that now I have what? 2 hydrogen on the left hand side. So I have to balance this up by adding what? 2 hydrogen plus 2H plus on the right hand side. So atomically, we are good. Sulfur was balanced initially. That's why I did not bother about it. So let's go forward. Now, in terms of the charge here we have a charge of -2 in this place in total. And here we have a charge of, this is -2 plus 2, and that is 0. Which means that the side with the higher amount of charge is this 0. This one is -2. So if we are going to add electron, we have to add electron to this side. And what is that? The difference in the charge is 0 minus -2, that is +2. Which implies that this guy needs how many electron? It needs 2 electron for it to be balanced ionically. And then this is balanced as well. So what do we notice now? The electron is being added on the product side. So what does that tell us? This is actually what? Half oxidation. This is half oxidation. So what I need to do now is that I need to actually bring these 2 equations out. The half reduction and the half oxidation. So for the half reduction, I have this here. So I'm going to bring that down here, right here. And for the half oxidation, I'm going to bring that to right down here. So let's have that. Okay, so now that we have the 2 of them here now, so what you notice is that, like I've already warned you before, I said that the electron cannot be on the same side if you have done a correct thing. If you have done a correct thing, electron should not be on the same side. So we are good to go here because Electron is on the left hand side for the first half, and electron is on the right hand side for the second half. So let's now go now and balance the overall chemical equation. The first step we need to do here is that this is 2 electron and this is 6 electron. They have to be matching together. So we have 6 electron here, we have 2 electron here. What we notice is that if we multiply this second equation by 3, then that will give us 6 electron here. But quickly, let's talk about a case whereby, let's say you have 4 electron in the first case and you have 3 electron in the second case. What will you do? What you do is that you multiply this up 1 by 3 and you multiply this down 1 by 4 so that you can balance everything up. But in this case, since 2 can be a multiple of 6, we just multiply 2 with that thing that will give us 6, and then we'll be done. So let's quickly get that. So if I multiply this whole thing by 3, that will be 3SO32 minus plus 3H2O. Then that would give 3SO4 2 minus plus 6H plus 6 electron. So finally, I will have to add these two equations. So for the sake of clarity, let me just bring this down right under it. So we have to add these two final equations together, and let's see what it's going to give in total. So we see that, let's bring out the ones that don't exist on both sides down first. We have SO3 2 minus there. So we have 3 SO3 2 minus plus Cr2O7 2 minus. We're done with that here. Let's go to the right hand side. We have 3 SO4 2 minus and we have 2 Cr3 plus. So let's now deal with the other guys. First of all, the electron part goes out. So they are both on different sides, so they will cancel out. Now when you look at water here, we have 3 molecules of water here, and down here we have 7 molecules of water. What is the implication of this? The implication of this is that the one with the higher side will take the overall net water. And there is 3 here, there is 7 here. What you have to do is to subtract them. 7 minus 3 is 4. We are left with 4 molecules of water. So what you do is that you add that 4 molecules of water to the one with the higher side. Let's go, we're done with water. Let's go with the hydrogen ion, H plus. We have 14H plus here and we have 6H plus here. So what we notice is that this side has the higher H plus and this side has the lesser one. But what is the difference? 14 minus 6, that is 8, and that means that this place we have 8H plus. And then that is the net balanced ionic equation. If you look at it atomically and ionically, this is already balanced. So let's quickly cross-check it. Our sulfur, we have 3 here, we have 3 of sulfur here. Oxygen here, 3 times 3 is 9. 9 plus 7 is 16. So let's see how many we have here. 3 times 4 is 12. 12 plus 4 is here. 12 plus 4 is 16. Oxygen is balanced. Let's look at chromium. Chromium is 2 here, and then it's also still 2 here. What about hydrogen? Hydrogen is 8 here. 4 times 2, 8. That's hydrogen. Let's look at the charge now. This is 3 times negative 2. That's negative 6. Negative 6, negative 2. That's negative 8. Plus 8. That is 0. That is 0. 3 times negative 2. That is negative 6. 2 times plus 3. That is positive 6. So that is negative 6 plus 6, that's 0. So charge-wise, it is balanced. Note that it is not compulsory that the net charge on the left-hand side is always 0. This one is just a coincidence. And it's not compulsory that the net charge on the right-hand side is always 0. What matters is that at the end of the day, the charge on the left-hand side must be the same as the charge on the right-hand side. So before I go, let me quickly do one that